In this tutorial, we will look at how to use Python to create a keyword cipher. A keyword cipher is a substitution cipher, which means that each letter in the message is swapped for a substituted letter to make an encoding. This is similar to Caesar, except that Caesar always shifts all of the letters by the same amount, but the keyword cipher uses a special keyword to generate a unique alphabet. An example would be if I was to choose the keyword Birkdale. I would then write out the alphabet afterwards. So Birkdale uses up these letters. A and B are part of Birkdale. So I would then use C. Then D and E are in Birkdale. So I would then use F. G, H, I is in Birkdale. So in this way we continue and we write out the entire alphabet. So I've got my keyword initially, Birkdale. I then have the remaining letters of the alphabet in order. Notice that in this case, we will have a lot of repeated letters because R is the highest alphabetical letter in my keyword. So choice of keyword can make a big difference to how your code turns out. It's always a good idea to start with a comment in the first line. So I'm going to say hashtag keyword encoder for school. Okay, so the first step is that we need to have an alphabet and the substitutions. So I'm going to put alphabet equals, and then inside speech marks, I'm going to have the whole alphabet, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. And I'm also going to have a space, which quite often features in messages that I'm going to send, and possibly also punctuation like comma, full stop, question mark, and also \n. \n is the new line character when you press the enter key, so it gives you new paragraphs. So I've got my alphabet. I now need to have my cipher, and I'm going to call my cipher keyword. And I'm going to move my equal sign just along a bit. The white space won't make any difference unless it's at the start of a line, in which case you could get indentation errors. But as it stands, I can put an extra space there so that when I type my alphabet, I will have the letters directly above each other, and it makes it easier to understand what's going on. So I'm going to type the keyword, which is school, S-C-H-O-O-L. Now, if I continue with this, I'll have too many letters because I've got a double O. You're not allowed to have more than one copy of any letter in your cipher. So I'm going to change that to SCHOL, S-C-H-O-L, instead of school. Now you remove the double O. I then continue to write out the rest of the alphabet. So I'm going to start A, B. I can't use C because C is part of school, so I skip over it and say D, E, F, G. I can't use H because that's part of school, so I skip over H and go to I, J, K. L is part of school, so I skip over that and say M, N. O is part of school, so I go P, Q, R. And then S is my last letter, so I should then be able to say T, U, V, W, X, Y, Z. And notice the top line of letters matches up exactly in length to the bottom line of letters. I can then put space, comma, full stop, question mark, and \n, just as I did above, so that if it finds those letters in the message, it will replace them with a copy of themselves. So, what I'm going to do? Well, I could say here, plain text, as in the message that you're going to give me, equals input, what is the message? And that would let me collect something from the end user. but I can make my life easier for testing here, and I can just say plain text equals, and I'm going to say, I've got to put it all in capitals. Substitution is better than Caesar. Now, I'm going to just comment out my input here so that it doesn't ask me for anything during the running of the program, but obviously it's only going to have one message that it can encode. So obviously you'd want to change that if you had your own program. So what I'm going to do now, I'm going to collect the plain text and I'm going to turn this into an encoded message. Okay, so I'm going to call it the ciphertext. And I need to take it off of caps lock. Ciphertext equals. Now we can call these things anything. We could call, instead of plain text, we could call it message. Instead of ciphertext, we could call it encoded. Doesn't matter what we call them as long as we're consistent throughout our code. So ciphertext starts out empty. Okay, there's nothing in it. And I'm going to say start with empty encoded. Then I'm going to make a for loop. I'm going to make a loop that goes through one letter at a time. So I say for letter in plain text. Now when I do a for loop, I always have to end with a colon. That tells it that what's going to come after that will be repeated. And the thing I want to repeat is I'm going to say position equals, I'm going to find the letter that's in the normal alphabet and replace it with the thing that's in the keyboard. So I'm going to say position equals alphabet dot find letter. So that will give me the position of the letter that is in my normal message, the S, U, and B of substitution, for example. And then what I want to do is add on to the ciphertext. So ciphertext plus equals, that will add it on to the end of the message. And that's going to be keyword, square brackets, position. So I've got a loop that finds the letter in my message and replaces it with something from the keyword. When I'm finished all of that, I want to print out the encoded message. So I've come back to the side of the screen after the for loop, back to the side, so that it doesn't happen inside the loop. And then I'm going to print ciphertext. If I run this code, you will see that I get a message like this. So we have created an encoder that uses the keyword school to make a message that someone would have to decrypt. Now what I'm going to do is I'm going to take that message and I'm going to make a decoder. So I'm going to copy that message. I've highlighted in the console and then I right-clicked and copied that. And I'm then going to go and create a decoder for this. So, up to here, click on plus create. It's going to make a Python replit called keyword decoder school. And I'm going to go through the exact same process. So some slight changes. So decoder for substitution. Okay, I want alphabet. I'm just going to alpha this time. Alpha equals A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. and just a space this time. I know that the message doesn't have any extra punctuation in it, so that should do. Keyword equals, and then it's going to be SCHOL, and then AB can't be C, DEFG can't be HIJK can't be L, MN can't be O, PQR can't be S, TUVWXYZ, and a space. And I'm just going to use some spacing here to line these up with each other. Okay, so message equals, and I'm going to paste in the message that I created. I'm then going to say decoded equals an empty message for letter in message. So there's my loop that's going to go through one letter at a time. And what I want to do, I'm going to say pause. So that's short for position. I can call it anything I like as long as I'm consistent. Pause equals. This time I find it in the keyword. Keyword dot, and instead of find, I'm going to use index, which does pretty much the same job. Keyword dot index of letter. And then decoded plus equals, and then I'm going to go to alpha, square bracket, pause. So that says go and find the same matching letter in the alphabet from what you found in keyword. That's adding them all on, and then finally I can print decoded. So, two separate pieces of code. They're just one of them takes alpha and matches it to keyword. The other one takes keyword and matches it to alpha. And they do that a letter at a time. If I run this code, then I do indeed get back my encoded message. To a casual observer, this would look like gibberish. They wouldn't be able to understand it. They would need to use some powerful cryptography techniques to be able to decode it. But we, with our Python program, knowing that the keyword was school, can very easily work out what the message is. So you'll get a chance to have a look at some examples of this. So there's a keyword encoder for the keyword Birkdale, a keyword decoder for the keyword Birkdale, and then you'll get a chance to try a few techniques for breaking the code. It's all about finding what is the arrangement of letters that has been used to encode the message so that you can then decode it and get back to the original. And that is the science of cryptography. Python allows us to very quickly try out lots of different alphabets and lots of different arrangements because the computer does all the substitutions for us, and that's why computers are so important in the field of code breaking.